In this lecture, we will see Euler's equation of motion for a rigid body, okay, when one point of body remains fixed. So, see, before this, I have like this diagram which will help you to understand things better. See, I have this axis, x, y, z axis. This is the space axis, okay, and I have named it as S. Then you have this rigid body, okay. Now, this rigid body is, I have already told you what is principal axis, right, in the last lecture. So, this body has its principal axis, and I have named it as x dash, y dash, and z dash. Okay, these dotted lines. Now, this rotation is happening with this frame of reference, that is s dash, x dash, y dash, z dash. This is its principal axis. Now, when this rigid body is rotating, also this principal axis, that is this frame of reference, will also rotate. Now, this rigid body is rotating with an angular velocity omega. Okay. Now, as I have told you that this principal axis which also rotate, you know what is principal axis? I will tell you again. I have already explained about principal axis in the last lecture. Principal axis is that axis of the body for which the we had the matrix, if you remember, the moment of inertia tensor, right? In that, if only the diagonal elements exist and other non-diagonal elements are zero, then we call, for such a principal axis, when such condition holds, then we call this axis as a principal axis. That means for a principal axis, when we consider the moment of inertia tensor, in that matrix we have only diagonal elements and the non-diagonal elements are zero in that case. Okay. Now, since this body will rotate with an angular velocity omega, so this principal axis will also rotate. So omega 1 is the angular velocity regarding along ox dash. Omega 2 is the angular velocity along OY dash, and omega 3 is the angular velocity along OYZ. Similarly, I1 is the moment of inertia regarding x1 x dash axis, I2 is the moment of inertia regarding y dash axis, and I3 is the moment of inertia regarding z dash axis. Okay, so this much basic is clear, so I can proceed further. See, this you have already studied in a previous lecture. Now I will now I will teach Euler's equation of motion. Euler's equation of motion is a set of equation governing the rotation of a rigid body referred to its own axis. Okay, what is it? Is a set of equation which governs the rotation of a rigid body referred to its own axis. Okay, such equations are called as equation of motion. This definition won't be clear now. When I will teach you this theorem, only then you will understand what is actually Euler's equation of motion. We will find such equations which will govern the rotation of a rigid body, and this rotation is about one point, that is about its own axis. So see, what does the theorem say? Obtain the Euler's equation of motion of a rigid body when one point of the body remains fixed. So see, before that there is one more concept, the concept of torque. So what is torque? Torque is nothing but the changes in the angular momentum with respect to time t, and this we consider according to the space axis. Okay, the frame of reference is the space axis. So see here, this generally we represent torque by tau vector, but in your notes it is given by n vector. It is same, you know what is tau. So the Greek alphabet tau, we represent torque by tau vector, but in your notes it is n vector. It's okay, it's just notation. So basically, what is the torque? torque vector or n vector is nothing but changes we record in the angular velocity, okay, with respect to the time t. And this torque is measured considering the space axis. As I have told you, there are two types of axis. One is the space axis and other is the body axis of the rigid body. Since now here we also know, we have studied more things. Now you also know what is principal axis. So there are two types of axis, body axis and the space axis. The torque, when I will consider, that is the changes when I will the changes that we are going to observe in the angular velocity are regarding the space axis. I hope I am clear. So now I have told you what is the torque vector or the n vector. Correct. Now this equation you have already studied in BSc, d by dt. Here whatever you take, no matter what quantity you take, no matter what quantity you take over here, this equation is always true. See, when you calculate the rate of change of some quantity, whatever the quantity is, okay, with respect to time t, considering the space axis, this will be equal to the rate of change of that quantity with respect to time t, considering the body axis, plus omega, that is the angular velocity, multiplied by the same quantity. Okay, now I need to find the value of dl bar by dt, and I have told you this is regarding the space axis. Basically I want to find the value of torque n vector. N vector is nothing but dl by dt with regarding to the space axis. So I know if over here I replace that unknown quantity with L vector, this side will become N vector, that is the torque. So what I will do, I will replace this quantity by L. So this equation is always true for whatever quantity you take. So now here I am replacing it by L vector. So equation 2 will become like this: dl by dt regarding regarding the space axis is equals to this. What I have done, I have just replaced this quantity. I have just put the value of L vector in this equation, but I know dl bar by dt regarding the space axis is nothing but the torque. This I have already told you in equation number 1. So this is nothing but torque. Hence now I will proceed with this equation. I hope I am clear. Now what I will do, I will observe equation number 3 and I will solve further. So now I will solve equation number 3. Okay. So next page we'll see. Now in equation number 3, everywhere we have L vector. Here also we have L vector. So first I will find the value of dl bar by dt. First what we will do, we will find the value of dl bar by dt. That is this equation, this side. Okay, then I will proceed and I will find the equation, or I will find the value of omega bar cross L bar, that is the vector product of omega, that is the angular velocity and the angular momentum. But first I will find the value of dl bar by dt. So before that we should know what L vector is. That is, we should know the, for some quantity which I will use regarding the angular momentum. This you have already proved in last question. L vector is equals to I dot dot into omega bar. What is I dot dot? Moment of inertia tensor. If you don't remember, I'll take it back. I'll take you back to that equation we have already studied. And you have also proved the value of L vector. Where is it? See here. This was, we have already solved this. L vector, see, L vector is equals to I dot dot into omega vector. What is this I dot dot? This is called the moment of inertia tensor. Okay, this we have already proved in the previous theorem that I have explained in the previous lecture. So now proceeding, since I've told you that we need to find this equation number 3, so for this you need the value of dl bar by dt. Before that you should know what L bar is. L bar is nothing but the angular momentum, and I have proved in the previous lecture that angular momentum is nothing but moment of inertia tensor into angular velocity. Okay, so this you already know. But over here, when I am considering the rotation of a rigid body regarding a fixed point, now since I know what principal axis is, I will consider the rotation of the rigid body, and I will choose the principal axis for all such calculations. And I know regarding the principal axis, when I consider the moment of inertia tensor, we had this matrix. If you remember, again I'm taking you back to the previous theorem. See, this was the matrix. But if I consider principal axis, I know only the diagonal elements would exist and the non-diagonal elements would be 0. Like all these values are going to be 0. The non-diagonal elements would be 0 if I consider the principal axis. So all these values are going to be 0. We have only the diagonal elements. So here what they are saying is they are saying that consider the entire calculation with respect to the principal axis. See, in this equation, I will read it out. What is it written? See, here I dot dot is the moment of inertia tensor and is constant with respect to the body frame of reference. We choose the principal axis of the body with respect to which the off diagonal elements, that means the non diagonal elements, of the moment of inertia tensor vanish and only the diagonal elements remains. Hence I dot dot would be this equation number 5 if I consider the principal axis, and they have replaced ixx by I1, I by y by I2, and izz by I3. This is just notation. So basically regarding principal axis, the moment of inertia tensor would become like this. So this you know you got. Now in equation number 6 they have just written omega in the form of its unit vectors. Okay, the vector form. Omega x is the a component along x-axis, omega y is the component along y-axis, and omega z is the component of the angular velocity along z-axis. And I bar, j bar, z bar are unit vectors. So replacing all these values in equation number 4, we will get the value of L bar. See here, I have got the value of L bar now. But what we had to find, see, we needed to find this thing dl bar by dt. So now what I will do, since I have got the value of L bar, I will differentiate it with respect to time. I will differentiate it with respect to time t. So now after differentiating it with respect to times t, since I know that the I1, I2, I3 will not change, they are fixed, they will not change with respect to time t. Since I have told you that the rigid body is rotating, also the principal axis will rotate, but the values of moment of inertia will not change. And I are the unit vectors, they have the same magnitude 1. So what will change with respect to time? Omega x, omega y, and omega z. See, they have put a dot over here. That means differentiation with respect to time t. So when you will differentiate this with respect to time d, I1 will not change with time. Okay, because moment of inertia does not change with respect to time. Only angular velocity will change, because when the body is rotating, then in any time, whenever the time changes, with it the angular velocity also will obviously change. So omega x, omega y, and omega z will change with respect to time t. So omega x dot, omega y dot, and omega z dot we have written. So this I have got the value. Now what I had to find? I had to find the cross product of omega and L bar. So now proceeding to find the cross product of omega and L bar. I have to find the cross product of omega and L bar. You know the cross product of vector product. Now the cross product is given by this. When you solve this determinant, this is, they have made curve, but actually it's determinant. It should have been a straight line. So finding this value, that is a determinant of this value, and after like some steps are missing, you should calculate by yourself. This is very preliminary. What you have to do, you have to solve this determinant. After solving this determinant, you will get some value. After that, what you have to do, you have to take few things common. You have to take I bar common, J bar common, and K bar common. Also, you have to take omega y, omega z common, and then you will reach to this equation. Try solving, it is really easy. So after solving and some simplification, omega bar cross L bar would be this quantity. Now using this equation number 8 and equation number 7 in the previous equation that we had to find, like this equation number 3, we will use both the values and we will find the value of n bar. So here we have got the value of n bar. See, we have got the value of n bar. Wait a second. This we have done. Yeah, see, we have got the value of n bar, and they have written n bar in the like using the unit vectors. Nx is the value of the torque along the x-axis. This is along y-axis, and this is along z-axis. So now we will equate both sides. We will take the coefficients of I bar common, then J bar common, and then K bar common, and see what we have got. We have got this nx, ny, and nz. We have finally reached, and these are called as the Euler's equation of motion of the rigid body with one point fixed. ठीक है, if I am saying that my system is torque free, then obviously nx, ny, nz would be 0. So this would be the equation of Euler's equation of motion of a rigid body about a fixed point, where we are not, that is, the motion is considered to be torque free. Then this is the equation. But if generally, where the motion of equation, sorry, the motion of the rigid body is not torque free, at that time I'm going to consider all the three equations, and these equations are called as the equation of rotation of a rigid body with Euler's equation of rotation of a rigid body with one point fixed. I hope I am clear. In the next lecture, I will complete this chapter, and then we will finally start with the unit number 5, which is our last unit. This is really important. These equations regarding your MCQ exam also you should remember. You should remember what these equations are. See, it is really easy to learn them. It is really easy to learn them. See, here they have nx. So they have ix. And it's cyclic. I1, then here I2, then here I3. With I1, they have omega x, omega y, omega z. In order to learn this, I am telling you, it's really simple. So you should remember these values, because regarding MCQs also it is important.